Hi 30-2s. Today we're going to be talking about laws of logarithms. So basically how to simplify logarithmic expressions when we are adding or subtracting logs that have the same base. Okay, so taking a look at the first law, again, which they refer to as the product law. Okay, they just walk us through some questions which kind of look like this. So they say evaluate the following. So in the first question here, log base 2 of 16, okay, that has a value of 4. So again, if you're confused as to how I do that quickly or how others may be doing it quickly, remember from last day we'd be going like this. Log base 2 16, I want to know what that equals, so I would make it equal to an unknown variable, and then I change it to exponential form. 2 to the exponent of v is equal to 16, so then I would say 2 to the v is equal to 2 to the exponent of 4, so v is equal to 4. Okay, so that's how I get that value really quickly. So basically I'm saying to myself 2 to the exponent of what gives me 16, okay, and that value is 4. Now plus over here, back to the question, log base 2 of 8, well 2 to the exponent of 3 is 8, so 4 plus 3, this gives me a total value of 7. Okay, so that's the answer to the first one there. Now when I go to the bottom, just underneath of that, they're saying what's log base 2 of 16 times 8? Well, that's the same as log base 2 of 16 times 8 is 128. What you'll see is that 2 to the exponent of 7, okay, equals 128. So those two answers, okay, were the same in A. Now in B, same basic idea they're having me do here. So log base 3, 27, that has a value of 3 because 3 cubed is 27. And in the second one, the answer is going to be, or the value of that logarithm is going to be 1. Remember, whenever the argument or the base and the argument are the same, the value is 1. So 3 plus 1 gives me a value of 4. In the question just below it, log base 3 of 27 times 3, well, that's the same as 81, and that will also be a value of 4. 3 to the exponent of 4 is equal to 81. And then real simply in part C, comment on your answers from A and B. Well, you can say I and double I, okay, have the same answers, okay? Okay, or the answers are the same, okay, however you want to word that so it makes sense to you moving forward. So that was the product law, multiplying. Quotient law, same kind of idea here. Log base 2 of 16 is 4. A log base 2 of 8 will be 3, so 4 minus 3 is 1. But you'll see just below that if I divide the arguments, log base 2 of 16 divided by 8 is 2. Okay, that's 1, right? Again, the base and the argument are the same, so that has a value of 1. And B, okay, log base 3 of 27, that's 3. Log base 3 of 3, that's 1. 3 minus 1, okay, that has a value of 2. And just below it, log base 3 of 27 divided by 3 is 9, and 3 squared, or 3 to the exponent of 2 is 9. So there's the value there. Again, answer or comment on your answers from what we just did. Again, I and double I, okay, have the same answer. Okay, so I'll just fill that in quickly and then we can move on. All right, so what we just took a look at in those two examples were the following, okay? The product law, okay, is talking about the following. When I am adding logarithms that have the same base, okay? You have to be adding and you have to have the same base. I can simply multiply the arguments. With the quotient law, okay, when I am subtracting log expressions and they have the same base, you can divide the arguments, okay? So you have to be adding or subtracting in these cases, and the bases have to be the same. Okay, if they are not, you cannot simplify by bringing the expressions together. So let's take a look at some questions and see if we can see how to apply this. Okay, so in A, log base 2, 12, subtracting log base 2 of 3. So again, we notice right off the bat, okay, that the bases are the same and we are subtracting. So that means I can do what? Well, I can go log base 2 of, and then I'm going to divide the arguments. So that's like 12 divided by 3. Okay, so that will simplify to log base 2 of 12 divided by 3 is 4. Okay, and that will have a value of 2. Okay, 2 to the exponent of 2 is 4. Okay, so there's the first one. In the second one, okay, I take a look at all those three expressions, and you'll notice all three of them have a base of 6. Okay, now we are adding and subtracting, so you can kind of do it one at a time, and that's kind of what I'll do here. I'll bring these two together first. So for those first two, I'm going to get log base 6 of, since I am adding 9 times 8, that's 72. Okay, so now I still have to subtract this log base 6 of 2. Okay, again, take a look. The bases are the same. This time I am subtracting, so I will divide the arguments. So it's log base 2 of 72 over 2. Okay, that simplifies to 36, and then that will be also a value of 2. 6 to the exponent of 2 is 36, or 6 squared. So there we go. Okay, there's the first two. Next page. Use the laws of logarithms, which are just what we learned on the last page, to write a log base x10 plus log base x75 minus, and then in brackets, log base x2 plus log base x3. Again, the first thing I notice, and you guys will, after you've done a lot of these questions, is that we're adding and subtracting here, but all of those log expressions have a base of x, which in this case is just the same base. That's what we're worried about here. So if I take a look at these two expressions here, that's going to become log base x of, since I'm adding 10 times 75, which is 750. Now I have to subtract, okay, what is ever in the brackets here, okay? And what's in the brackets there are these two log expressions, which will be log base x of, since we're adding 2 times 3 is 6, okay? So what I'm doing now is subtracting log expressions that have the same base. So I divide the arguments. So it's log base 6 of 750 over 6, okay? And when you do that division, you will get log base 6 of 125, okay? And there you did. You wrote it as what they asked you to do as a single logarithm. So, oops, sorry you guys, I didn't even realize I was writing log base 6 there. This is just supposed to be an x, okay? So just change those to x's again. My apologies. Okay. Now, part B says evaluate if x is equal to 5. So now I can take that expression, log base x of 125, and that now becomes log base 5 of 125, and that will have a value of 3. Okay, 5 to the exponent of 3 is equal to 125, so that value of that logarithm is 3. Okay, moving on. So a good question here, kind of a multiple choice type question that you might see on a quiz or a test. And again, they're just asking you which of the following expressions is equivalent to the one that they've provided for you. So when I take a look at the expression that they've given me, again, I take a look. I'm only adding or subtracting there, but all those log expressions have the same bases. Okay, so again, I am adding and then subtracting, so I'll deal with these two first. That'll give me log base 2 of, now I have to multiply x by 2x, so that's 2x squared. Now I still have to subtract this, which is log base 2 of x squared. So at this point now I'm dividing log expressions with the same base. So you're going to divide the arguments like so. So it's log base 2 of 2x squared over x squared. That will simplify to log base 2 of, okay, the x squareds will cancel, so leaving you with log base 2 of 2, okay, which we know has a value of 1. Okay, so your answer in this case is D. Great. Next question, okay, determine the value of 3 log base 2p minus 3 log base 2q if p over q is equal to 8. So in these types of questions, these little pieces of information they give you are usually the key, okay, and the reason being is that if you see an 8, you're going to replace it with p over q. If you see a p over q, you're going to replace it with 8, okay, they're telling you they're the same, so they're interchangeable because they are equal to one another. So when I take a look at the expression they've given me, the first thing I notice is that there's a 3, okay, in front of each of those terms. So I'm going to start by factoring out the 3. So I'm going to have 3, and that'll leave me with log base 2 of p minus log base 2 of q. So inside there, I'm now subtracting log expressions with the same base. So I can make this log base 2 of p over q. Okay, and there's that key piece of information, right? There's the p over q, okay, that I was worried about, okay, or looking for in the question. So now I can rewrite this as 3 log base 2 of, and instead of p over q, I put 8. Okay? And log base 2 of 8 has a value of 3. 2 to the exponent of 3 is 8, and 3 times 3 is 9. Okay, so there's our answer for that question. Okay, so working with the product and quotient law, mostly there, and just seeing how they kind of come together. So if you want to take a break and work on questions 1 to 6, that might be a good idea, and then come back and you can hear what I have to say about the power law. I'm just going to keep teaching, so if you understood that perfectly and you want to just keep moving on with me, then that's also fine. So the power law. So here's what happens here with the power law. So a different one that we're going to learn now. It says, now, by writing 2 log x as log x plus log x. So what they're saying is 2 log x's can be log of x plus log x, right? Because if I take 2 log x's and add them together, I get 2 log x. They're saying show that 2 log of x is equal to the log of x squared. So I start with what they gave me, 2 log of x. Okay, well, they've told me that's the same as log x plus log x. Now, in that expression I've just written, I am adding logs that have the same base, right? You don't see them here, okay? But don't forget that when I don't have a base, it's actually 10. But the point being here is that I am adding log expressions that have the same base, so therefore I can do what with the arguments? Okay, I can multiply them, and x times x is x squared. And that's what I did. I showed that I started with 2 log x, and I ended with log of x squared, okay? And that's what they wanted me to do. In B, okay, same basic idea. They're saying if I have 3 log base 2 of a, well, that means I have 3 log base 2a's. So I could say that's log base 2a plus log base 2a plus log base 2 of a. I have 3 of them. Okay, so I just wrote them out individually. Well, in that written out expression, I am adding log expressions. They all have the same base of 2. So I can simply multiply all the arguments together, a times a times a, which is a cubed. Okay. So what they're trying to get me to see here is in part C, they're saying write an expression equivalent to a log base b of c. If you take a look at those first 2 questions I did, see how I had the 2 at the front, 2 log of x, that ends up being an exponent up here. Same thing in part B, the 3 that's in front of the log base 2 of a ends up being the exponent attached to the argument at the end of the expression. So if I use that same logic here, the a that is in front of the log base b of c, okay, will end up as an exponent attached to the argument right there. So there is the expression that is equivalent to the original one, okay? So that takes us to the power law of logarithms on the next page, and you can see the same basic idea here. That n, which is an exponent attached to the argument, can also be written in front of the log expression, okay? And that's what they're gonna have us practice here for a little bit, and then we'll try some questions, okay? And then you're into your assignment. So it says write the following in the form n log x. Okay, so they want that value in front of the log x. So in the first question, that exponent of 10, I'm simply going to move down in front of the log expression. So it's just going to be 10 log x. Okay, and you're done. In B, a little more work here because we have the root of x. Well, that's the same as x to the exponent of 1/2. So there's the exponent that I wanted. Now that exponent comes down in front of the log expression, so it's actually 1/2 log x. Okay, perfect. Now, in the second set of questions, they're just having us go the other direction. Okay, so this time they want the question written like this, where that value of n is attached as an exponent to the argument. So they've given me 5 log x. Well, that's the same as saying log x to the exponent of 5. Okay, like so. And in B, same basic idea. This is going to be log of x to the exponent of -1/3. Okay, so pretty straightforward in those first 2 questions. Now, in the next set, write the following in the form n log base b of x and evaluate. Okay, so I have to write it in a certain form and evaluate it. So when I take a look at A, what I can do is this 2 that's an exponent attached to the 8, I'm going to bring it down in front. So 2 and then log base 8. Okay, so this is going to mean 2 times what log base 2 of 8 is, and that's 3, right? Because 2 cubed is 8. So 2 times 3 is 6. And there you go. Okay, hopefully that makes sense. Now in the next one, I have a 6 that's already in front, so I'm going to put the 6 here, okay? And then inside the bracket, I'm going to take the 3 and put it down here. So 3 log base 49 of 7, like so, okay? So what happens here is I have the 6 inside the brackets here. I have 3, and log base 49 is 7. Well, that's actually 1/2, isn't it? Because 49 to the exponent of 1/2 is 7, or when you take the square root of 49, you get 7. So what happens here is now you have 6 times 3 times 1/2. Well, that's like 18 times 1/2. Okay, when I multiply, the order in which I multiply doesn't matter. Okay, so this gives me a final value of 9. Okay, so I have evaluated it. In C, okay, so that 6 here is still on the outside. What I want to do is figure out what's going on here with the log expression. So this is going to be log base 49. Now this is going to be 7 to the exponent of 1/3. Okay, that's how I replace a cube root. So again, that exponent of 1/3 comes down in front of the log expression. So there's the 1/3 now. And again, log base 49 of 7. Now we should know what that is from the last question, right? That's going to be 1/2. So I have a 6. I have the 1/3, and now log base 49 is 1/2, isn't it? So 1/2 times 1/3 is 1/6 times 6. Okay, so that is 1. All right, last one here. So this one, just kind of a general case. So this n up here is going to become a value in front of the log. So now I have log base 6 of 6. Okay, we know when the base and the argument are the same, the value of the logarithm is 1. So n times 1 is n. And there you go. Okay, good. Last question. Okay, so in the last question, they're just saying use the power law to prove. Okay, so when they use the word prove, they meaning basically show that what they've given you on the left-hand side of the equation, okay, can end up looking like what's on the right-hand side of the equation. So I will start by just writing down log base 4 of 16 to the exponent of x. Okay. Now, using my laws, my power law, I'm going to take that exponent of x and move it down in front of the logarithm. So x log base 4 of 16. So this will be x. Now, log base 4 of 16 is basically 2, isn't it? 4 to the exponent of 2, or 4 squared, is 16. And we know x times 2 is the same as saying 2x. And there you go. Okay, I started with what they wanted me to start with, and I ended with what they asked me to end with, which is that 2x. Okay, and that's it for today's lesson. So hopefully that made sense to you guys. Again, any questions, forward them to me, and I'll try and get back to you as soon as I can. Again, hopefully these lessons are making things a little less stressful for you, and you guys are all staying healthy and are having a good time at home with your parents.